Good afternoon, everyone, and welcome to another Big Data London webinar. Today's the next in our series of technology modernization, and we'll be focusing on NoSQL technology today. I'm Andy Steed, Content Director of Big Data London, and joining me today is Ankit Patel of Datastax. Hello, Ankit.
Hi, how are you?
Yeah, good, thank you. And Juliano Altamura of Fincons. Hi, Juliano.
Hi.
So these sessions are designed to be interactive. Please send in your questions during the presentations, and I'll endeavour to ask as many as I possibly can at the end of the sessions. But without further ado, I'd like to pass over to our first presenter. Over to you, Ankit.
Great, thank you for that, Andy. All right. Thank you for the opportunity to speak today, and welcome to the webinar. My name is Ankit Patel. I work at Datastax, and today we're going to be talking about an important topic that interests a lot of us on this webinar, which is migrating from RDBMS, which is considered to be a monolith, into a transformational data architecture. So one of the key questions you may ask is why move from RDBMS monolith to a transformational data architecture? And that really has to do with the history of RDBMS and the technology being itself 30 to 40 years old, and the need to achieve these business outcomes, as you may categorize as transformational outcomes. And some of those needs are being able to operationally scale, taking on new users, acquiring new users, which grows the demand and volumes of the data, the need for digital security, no matter where the data lives, the need for content management, better content management, and data generation, the need for an IoT or 5G platform, and really to do e-commerce as well. So given those business outcomes that you're trying to achieve, what are the key data constraints that you may have to achieve that in the new system that you want to design? And it really has to do with the relevance of data. Make sure it's driving business intelligence and insights into what you're actually storing and retrieving. The accessibility of the data is very important as well. You want to make sure the data is accessible no matter where it lives, whether it be in multiple data centers, any region around the world, any zone you refer to. And the scale of the data is also important, ensuring that you're able to grow from 100 user bases today to 1,000 tomorrow, to 10,000 in the future, and 1 million in sometime in the future. Just want to be able to address the scalability aspect of how that data is accessed and digested from the application stack or the end user, whether it be internal or external to your organization. And to think about all this, you also want to consider sovereignty, which is really the security of the data, to ensure no matter where the data lives, whether it be on the user end devices or within different regions around the world or data centers around the world, you want to make sure the data is absolutely secure. You don't want it to be in the news, the market news, to impact your organization directly. So you have to ensure the data is secure. And the agility of the data is also very important. You want to ensure that the data is able to move around at a quick pace, and you can twist and turn the data at a really fast speed, so you can meet new market demands. And of course, we've talked about it in the past, is that the availability is also a key aspect of a characteristic that you may need to address as you think about your business outcomes. So how do we achieve this? So we at Datastax work on top of Cassandra. Cassandra is our key foundation. It's to achieve that transformational capability that you may be looking for. What Cassandra offers out of the box is 100% uptime, zero lock-in, so you don't actually lock into a specific cloud provider or an infrastructure, for example. And it also offers global scale. So you're able to scale linearly from hundreds of transactions to up to millions of transactions per second, if that's your use case. And what I want to highlight here is basically the need. Cassandra would really the capability of Cassandra is the availability, no matter where you deploy your data. So Cassandra offers this capability of being 100% available, and it could be your cloud native database. So you can deploy Cassandra on any major cloud provider on premises, on a VM-based solution, and you can easily achieve 100% uptime no matter where it lives. And really, that architecture is engraved in the technology itself, and that's essentially, the backbone of how Cassandra works. It's a masterless architecture, and you want to ensure that you're designing around that paradigm. So your data is available in this new transformational data architecture, no matter where it lives. So when we think of Cassandra, Apache Cassandra, the open source project which Datastax backs up, it's really our foundational layer. And what it's really missing is a trusted layer, which offers you the operational capabilities on top at ease, and then the accelerated layer, which is geared towards developers. So you can consume Cassandra, but it's really difficult from the development perspective to interact with it, and being able to index the data from a Cassandra perspective or read and write information at ease from a development perspective, take that application or microservice into production. And then, the strategic vision is there from an open source perspective. We at Datastax have done a lot more from a strategic perspective to achieve the business outcomes that you're really looking for on top of Cassandra. So that leads us into this next slide, which is more about how we have offered from a Datastax perspective, these layers on top of Apache Cassandra, which we support through one of our product offerings called Luna. We offer 24/7 support to the enterprise that we work with Apache Cassandra. But however, we also have this additional product on top, which really helps you in the operational capabilities of Cassandra, which gives you advanced performance, enhanced security and monitoring needs that your organization might have. And on top of that, the trusted layer is really focused around our operators. And then we have a focus layer around our developer, which is the accelerated layer, which gives you that multi-model capability, the analytics that you may be looking for streaming or batch operations with Spark. And then we have this capability of enhanced search, which has to do with your need to actually get data outside of the primary key, and you're not able to go through a rigorous data model redesign on top of Cassandra. So, through our accelerated offering around enhanced search, you're easily able to do that. And then with an additional functionality, we also offered the graph engine, so that allows you to basically model around a multi-entity design pattern where you can easily traverse through many relationships at ease through the acceleration that we offer. And the graph engine, you're able to digest and traverse through many relationships across many partitions or tables within Cassandra, and the core data still lives in Cassandra. So, and the relationships are also built on top of Cassandra. So it's very easy for you to develop a graph data model. A simple example is customer 360 or fraud detection use case that you can easily do on top of Cassandra with what we offer. And then we also, from a Datastax perspective, offer extensible integration that plugs in easily with bulk loading and unloading needs, your Kafka connectivity needs, your Elasticsearch needs. So we offer that capability from a Datastax perspective. And then we also have the strategic vision, which is around ensuring that we are thinking about the future and ensuring that we are Kubernetes enabled. So we have recently launched the Kubernetes operator from a Datastax perspective, which is backed by Datastax. We've open sourced it, so you're more than welcome to consume it. We have this focus around the development aspect of things and making sure that you can do higher order functions and don't need to communicate with CQL directly. So we will have offerings around the REST and the GraphQL capabilities on top of your data that lives in this data platform. That is backed by Apache Cassandra at the foundational layer. And then, all that is leading to the outcomes, which is really, your business needs to be having AI experiences, microservices, and driving insightful decisions on the data you store in this data platform. So that really, that is really our point of view and how we've actually conversed to this point of view, working with many enterprises over the last few years. And we have a commitment to open source at the foundational layer, just looking over to the right here. And we want to ensure that, we're committing back to the community. We want to ensure that, we're driving better partnerships. We offer world-class enterprise support. On top of that, we have thought leadership that we strategize around internally as well as externally with many organizations. And then we also offer a lot of tools on top of the products that we offer, that be Cassandra itself, or whether it be a Datastax specific product on top of Cassandra. So what that's leading to is our commitment to an enterprise success story. We want to make sure we're valuing the partnership with the enterprises that we work with. We want to ensure that we continue to build on this foundational layer and continue to invest in the open source community. We want to ensure that we continue to invest in a trusted layer, ensure that the operational aspect of Cassandra becomes very easy and predictable as time moves on, whether it be the open source offering or whether it be a Datastax product or whether it be a managed solution that Datastax offers. And then we want to ensure that we are accelerating the development experience and the need to access this data at ease from a development perspective, and really to drive strategic vision within the many enterprises that we work with, and ensure that we're really about driving the outcomes that your business or your entity is looking for, which is top line revenue growth, or being able to de-risk the data or modernize an application or a platform that lives in this monolith of RDBMSs. So really, why is this so challenging? Given that Cassandra has been around for many years, and we've done this with many enterprises, why is it so challenging to migrate from RDBMS into Cassandra? So it really comes down to the design paradigm of ERD-based design versus a query-based design. So RDBMSs, or mainframes you can claim, are around this ERD-based design model where you have constraints and you have entities which are interrelated, and all of that comes down to your schemas and your tables, which are some sort of interrelationship through foreign keys and indices that you may be creating, and triggers and stored procedures that you may have in terms of the business logic that you have engraved into these ERD-based design patterns. And really, when you transform that into the new NoSQL world, the query-based design pattern, that becomes a challenging task in itself, and we've seen it happen with many enterprises that we've worked with. So we want to ensure that we're addressing some of those challenges in this webinar here, and that leads us into this next topic around how can my enterprise get from an RDBMS based design to a transformational data architecture. And that's really we've seen this notion of the lift and shift workload, where you say let's take the entire RDBMS ERD design pattern and lift it at once and shift it into Cassandra. So that's really the boil the ocean problem, and that has a lot of challenges. That in some business use cases you could technically do that, depending on the impact on the end user or the application stack, and how many applications are actually designed around that. But if it's a fairly complex application for it, you're relying on it around many critical business functions 24/7, that generally will not work. That will introduce a lot of downtime and a lot of high-risk activity, which the business might not be okay with. So, we've seen it happen in some cases, but generally, lift and shift will not work, and you really don't want to boil the ocean at the same time. Lifting, shifting a table-by-table migration generally does not work, because RDBMSs have these constraints which also need to go across tables. So, and you can say that if I'm constrained to a specific table, then I can migrate it all at once. But if that table has relationships with other tables, of which the application stack or microservice is pointing to, then it's going to be very hard to lift and shift that specific table into the NoSQL world. So that in itself has a few challenges. So you really don't want to be in the mindset of let's take a table by table approach. And then it's the other challenging thing that we've seen is nearly impossible to rewrite the application stack. It's expensive to do. It takes a lot of time, and it's too much risk, and it might require downtime in some cases. So the biggest issue that between the two systems, RDBMS and NoSQL being Cassandra, is the data model being different, the query-based design versus the ERD design pattern, again, just to reiterate. So this comes at, so over the years, we worked with enterprises, and we've really come through and said that, there's a simple ETL compatibility that we can we can hook in, which is called the Kafka connector that Datastax offers. It's a simple connector, so once you put information into the Kafka queue, it's able to sync directly into the new table in the Datastax platform into Cassandra, you can say as well. And that really has to do with building a CDC toolkit. So the CDC toolkit is something that is capturing the information from your RDBMSs, your mainframes, whether it be flat files, RDBMS directly, or mainframe, and captures through some timestamp-based approach, that's some table differencing tools, or some trigger-based application, or log-based analysis. And the CDC tool is capable of taking the source schema and transforming it into the target schema, applying DDL changes, filtering. And then it's also able to do data type mappings as well if Cassandra doesn't support the data type that your source RDBMS has, for example. And what it does is it puts that transformation directly into the Kafka queue, or the destination. And if it's Kafka, for example, then you can take directly and apply our Kafka connector. And what that will do is simply just take the information from Kafka and dump it straight into the Datastax platform. And then the outcome of that is your modern applications, which, whether it be JSON, key value, graph, tabular, can hook directly into the new platform. And this syncing would happen at a frequency that you would decide on a daily basis, by the second, every 10 seconds. So this is something that we worked with many enterprises to do. However, this is great, and this is still a near real-time approach, is what I want to highlight in this specific slide. The next topic is basically, how do I actually add business intelligence, the transformation that I'm looking for, to ensure that I can detect fraud before I put it into the destination, which is the Datastax platform, where I can actually do very complex business logic and drive key business decisions and insightful information before I actually put it into the destination platform. So we also offer the analytic platform, which is Spark, and through Spark streaming, you can actually take the information through the same pipeline directly from Kafka or the same source system, and apply it in Spark and do that complex logic or algorithm that you may want to do on your source data before you put it into the destination. So this is one way you can do that. However, this has challenges in itself, and this is still not real time. This is still near real time, or this still might be latent depending on what you're doing here. So the data ends up here, but still it might take for example, a few milliseconds due to this extra middleware that we actually put in the play. So the third approach is really just to reiterate, we have two approaches. One is through Spark streaming, and the other is to Kafka Connect. And you can build this pipeline, ETL pipeline, from your source system to the destination system through which data will live in a highly available system backed by Cassandra, and have this accelerated capability, so your application stack can benefit from all the transformational constraints that you had in place when you initially started the new redesign. So to really think about this, that still adds a little bit of latency. And then, so we've partnered with many enterprises again in the past to think through this design paradigm, and said that possibly what we can do is, instead of doing Spark streaming and then into the data platform, you can still continue to do Spark streaming and put meaningful information in your data platform. You can still do the Kafka connector and put it into the data platform. However, to bypass all this middleware here, as you can take your CDC tool that you've designed and take the information from there and take it straight into the destination data platform. We have connectivity tools and drivers that we support from a Datastax perspective. We support many different ways of doing this, through bulk loading, through direct driver connectivity, as well as we also support RESTful API interfaces. So you can technically take the CDC tool, and the CDC tool can be your source as well. So your clients can actually connect to this CDC tool to write information both in the old system as well as the new system. Or the CDC tool can be the afterfact of taking it from the mainframe or RDBMS as a polling or as a change data capture and pushing it straight into Cassandra. So Cassandra in itself being high available, you don't need to worry about, what if I fail writing to the destination? You can design around that with multiple region, multiple zones, multiple data centers. However, if you still are, debating whether should I be really doing this and bypassing this middleware, you can at minimum put the Kafka layer to ensure that whatever CDC mechanism that you designed around here, you can persist it in the messaging queue and then take it into Cassandra. But if the messaging layer is adding too much latency and you want to make it as real time as possible, you can take it from the source CDC tool and dump it straight into the data platform. So how do we actually do this, right? So you want to think from a methodology around divide and conquer, and to accelerate this transformation, you really want to address this from a business function perspective. So you want to highlight all the different business functions that your old system is valued around, and you want to transfer one business function at a time instead of transferring one table at a time or doing a lift and shift. You can technically say that this specific business function I can do a lift and shift around, but if you have a problem doing that, you can build a CDC pipeline and do a transformation in near real time based on the 3 different designs that we've spoken about. And part of this process is you need to ensure that you are determining the proper scope, and you ensure that you understand the dependent data structures and the business needs around what you're actually transferring. And then you want to identify and write and read patterns associated with that data structure, and ensure that you may want to build the CDC pipeline, and from the application stack or the end user, you may want to have the reads go to the new system first, and possibly have the writes still go to the old system, and then eventually you move the writes over. Or you can decide to move both reads and writes over at the same time, or you can just say that this is my true replica in my destination, and I will use it in based on what my business need is. If my volumes are growing, or if my new use cases go on this new system as the data is being synced from the old system to the new system, and I really don't have a need to move away from the old system, but I want to ensure that my new innovative projects are going on the new system, but I need that data there, and that's where you really build that CDC pipeline for. And then what you want to ensure is you're tackling the right data model, and it's optimal with the new design pattern around Cassandra, which is a query-based design. So you don't want to be in that mindset that let me do an ERD design pattern on Cassandra. You do need to transform that, and you want to ensure that you're doing it correctly. And again, to reiterate, the CDC pipeline will help you, in the transformation, as well as driving business intelligence if you need to during that process, and making it to the destination, which is backed by Cassandra and backed by Datastax, where you can easily sleep at night and say that my data is 24/7 available. I can access it from any application stack, and I know that I can scale linearly with the new demands that I have in my business, as well as I can drive better accelerators and more strategic direction with my data, having it in one data platform. And you want to really design around the microservices framework in this new transformation that you do, so you can lift and shift specific microservices at need, or you can transform them as your business needs change. So the goal of tackling some of the things in the past slide is basically to return a transformation value fast and predictably. You want to ensure that you are building around a proven and a repeatable process. You crisply define business functions along with their priority for transformation. You perform adequate testing of the data model. You use microservices and standardize around interfaces to avoid developer disruption. And you want to perform live migrations by abstraction, which may require real-time CDC pipeline and transformation. And you want to build active and batch reconciliation tools to find the delta. So you may ask the question, I'm building this ETL pipeline. How do I ensure my data from the source and the destination is absolutely in sync, or there's no delta? So you may want to think about, how do I run active reconciliation? How do I run data that has been migrated in the last hour and compare and ensure that I inform and log the information to the interested party to ensure that, let's fix the issues or the bugs associated with the replication of the data. And then you might want to do a batch reconciliation maybe once a week or once a month, saying that, let's take the entire data set and compare it and ensure that there's no differences in case you missed it in the active reconciliation workflow. So, how does Datastax actually help? So this is a real life example of an enterprise that I worked with in the banking industry, where we've taken an application stack which was on the mainframe or RDBMS, you can claim. In this specific case, it was on DB2. And we built this CDC pipeline, which Datastax helps you accelerate. And we built it on top of the Datastax product, which with all these accelerators. And what we've done is, from the API stack, the API is able to access, read, and write data to this new operational layer, as well as have connectivity to the old layer as well. And then over time, what we've done was we migrated from this layer, the old layer, into the new layer, and treat it as the source of truth. So, and in this specific migration, they no longer had the need to use a mainframe RDBMS anymore, but you can very easily argue that, I still need my mainframe, so you still can keep that pipeline active if needed. But, you can ensure that through the reconciliation process that we've developed, we've talked about in the past slide, that, your data in the source in the destination is absolutely in sync and is accurate over a period of time. So, at Datastax, with what it offers on top of Cassandra, you're able to build these accelerators at ease and, create this pipeline with confidence that, we've actually done it with many, many enterprises in the past. And, that really drives a lot of business value with these new transformations around, I have a new mobile banking app, or, I need to have customers offer peak volume times when they get their paychecks, for example. So some of these needs might not be, suited for the RDBMS role, or you may want this data to be available across many regions, or you may have the need to scale this data depending on the user demand. So really, just to reiterate, what Datastax helps with from RDBMS to microservices architecture is that basically at the high level, we take a business function from your enterprise RDBMS environment and transform it into microservices. So we've helped many enterprises, and more than happy to do so with anyone on this webinar, is that from a high level perspective, we help with API object and scope definition. We help with NoSQL data modeling. We help with a persistent layer, operational automation template, scaling plan, test automation framework. And we also help you build that CDC pipeline if you need guidance, or actually, need some partners that we work with that actually have done that with the enterprises that we work with, that based on the Datastax product or Apache Cassandra per se. And then, we also have a Spring framework-based microservices architecture approach that the organization is sold on the Spring framework itself. So, this slide is not really about, the kudos that we've gotten over time, but this is more about, how we've actually partnered with many, many enterprises and actually, take lessons learned and have applied it into our product to build a better product and ensure that, we can drive some of these transformations that you may be looking for in the near future. And, I personally have worked with many of these logos myself, and have experienced, the transformation that we've gone through internally at Datastax from a product perspective to build those accelerator trusted, and as well as the strategic layers that we referred to a few slides ago. So, that sums up my piece of the presentation. I want to thank you for taking the time to go through this presentation with me today, and I look forward to speaking with you in the future. And I'll give it back to Andy.
Thanks, Ankit. Yeah, thanks very much for that. Before I welcome Giuliano to do his presentation, I just thought I'd pick up on a couple of things. Firstly, for anyone who joined the presentation a little late, this is available on demand almost instantly after we finished. So that applies for as well if you'd like to have a look at some of those slides again. Maybe go, have a look at some of the slides. You can rewind or fast forward and get to particular bits that you want to. You'll be able to do that straight away afterwards. However, without further ado, I'd like to bring on Giuliano, who's going to share with us some use cases of this technology. Over to you, Giuliano.
Thank you for that, Andy, and good afternoon to anyone It's a pleasure to have the opportunity to share our experience that we did in particular on data architecture and modernization projects. Let me just share the screen. Okay, I should be there. Okay, so my name is Juliano Altamura, and I'm responsible for the financial services business unit of Fincons Group. Fincons is partnering with Datastax since 3 years now, and we had the opportunity, I can say, to experiment the benefits which Ankit just well summarized in his presentation. Before starting, let me just spend 1 minute to tell you who Fincons is with this slide, where you can see that Fincons is a system integration company with 1,700 professionals active in 6 countries, Switzerland, Italy, UK, Germany, US, and lastly, France, where we opened our offices beginning this year. We are doing well with the continuous growth year after year, and this is enabling us to invest both in new geographies and also on new technologies with the continuous research of providing new value to our clients, in particular, of course, in the digital transformation space, where we are very much involved. About our services, we do a kind of 360-degree services to our clients, from the high-level consulting, business consulting, and so on, down to the delivery services, IT services, so meaning system integration, system building, application management, and so on. We are well distributed over the different industries. Financial services, which is the one I lead, is more than 1/3 of our total revenues, but as you can see, we work also on many other industries. We are here to talk about real cases of using the technologies that Datastax is well providing, and in particular, I'm here because it's in the financial services space, so banking and insurance, that we experimented in particular those technologies. In particular, what we have in front in this period is a huge wish to invest from our clients' perspective into the digital transformation. Digital transformation means implement new touch points in order to have every person, every user connected with the organization, possibly in real time, also on the go, so let's say with mobile devices and so on, and in particular to have applications that are nice looking, with a nice user experience, in order to make our users happier and more productive. So for implementing these front-end applications, we have to face a number of challenges. So as I said, mobility, integration, of course, is probably the most important topic. Time to market, which is more and more the number one, one of the number one priority, as well as costs, of course, flexibility, because we want to build something that can last in the future and can be, enlarged month after month. Of course, UX is another challenge, user experience, and last but not least, performance. So how Fincons is managed to address all of these challenges? In particular, talking about developing front-end applications, the first receipt is to use new modern technologies for building front-end applications. So using single-page web applications, so we HTML5, CSS3, Angular, React, and so on, in order to have really fast applications from the front-end perspective. Secondly, it's important to use a modern integration model, so work on microservices, integrations, but it's not enough, because if you implement these two layers well, you will have a very fast front-end application, but this will just highlight the real problem, which is the time you have to wait for accessing the data. And for this reason, we need something more. And this is where we developed our solution, which is called Fincons Fast Data Lake, which is based on Cassandra from Datastax, and has the ability of completing the addressing of the challenges. I explain you how. This is the traditional design for a high-level architecture of a front-end application at enterprise level. So on top here you have the touch points applications. You have an API gateway, maybe an enterprise service bus, something for simplifying the integration. And typically you have to integrate your legacy systems, which may be providing services, web services, or also external systems. So what happens in most of cases, in particular in the insurance and banking sector, it's the majority of the cases, but I'm pretty sure that it's very similar also in other industries, that it happens that the legacy systems are not a single system, but are a set of systems, because applications are often siloed into different systems. This is furtherly complicating the work for accessing and retrieving all the data that we need, in particular for particularly complex front-end functions like 360 degrees picture of the client, or if you have to implement profiled cockpit, and so on. So what is our solution? Is that first of all, this architecture here has some limits, no? Because we have that all the touch points that you will build now or in the future are insisting on the same legacy systems. So if you need more capacity, you have to go there and invest maybe in expensive technologies, maybe mainframe based, and so on. So this is the first limit. Second is the peak of load from new touch points, because these new touch points are often exposed to the web, so you have an unpredictable usage, no? So you may have peak of loads, and you have to size your backends in order to manage these peaks. And so again, it's a matter of sizing probably an expensive system, and so that's not the best choice. 24/7 availability is another point where many companies has problems in providing. And last, as we said before, performance for enabling engaging UX, because if in the case of particularly complex pages or applications, you at the end will wait for the slowest of the legacy systems. So how can we overcome these limitations of the legacy system? By introducing the Fincons Fast Data Lake solution, which is based, as you probably have understood, on a data lake, based on a NoSQL database, Cassandra, and with a real-time data ingestion in order to have a fresh image of the data into the data lake, and in order to be able to build APIs to get information not anymore from the legacy system, but directly from the data lake, so with a much faster performance. The architecture is, I would say, similar to the one that Ankit just explained, based on the CDC pipeline. By the way, we experimented almost all the strategies, the data migration strategies that Ankit was explaining. But at the end, on the left side of the picture, you have the data sources, which could be internal or external system, could be also IoT sources or open data sources, it's not a problem. And so then you have this ingestion and enrichment procedure, which is really the core of the application, of the solution, which is capable of mirroring the data into the data lake. Not only mirroring the raw data, but also enriching the data. And this enrichment, we do it without writing code, but by configuring some rules into an engine that we built, in order to have on the data lake the raw data, and also we call it a vertical representation of the data, which is really ready for the API, for the specific APIs that will feed the digital touchpoint applications. I would like to emphasize the fact that this is an end-to-end solution, because it's if one is experimenting for the first time this type of technologies, which are almost new to many, it will quickly realize that on the market there are tens or hundreds of possible components that it's possible to choose to implement a similar solution. So we believe that it's really important, or it's really a value for our clients to have to provide an end-to-end solution, so something that is really complete and enabling this kind of architecture. Of course, once you have done this for providing data to your digital touchpoints through the APIs, you will be able also to use it for business intelligence purposes. Last slide I would like to share with you is coming from the most important implementation of the solution that we did for ITAS, which is the sixth larger Italian insurance company, and where we implemented this solution, and we implemented some important use cases. So the first one is being this portal for claims managers, and we implemented on this solution a profiled dashboard with alarms, with expiry dates management, next best action, and so on, based on the data lake and on the solution that we just saw. The value of this is that in real time, this portal is fed with the real-time information. So if they have an alert, for example, on a client, they can manage that particular problem. They get back into the dashboard and they find the data updated, even if they are updated on the backend systems. The second use case is probably the most used, the killer use case, I would say, for this kind of solution that I saw used on many insurance companies and also banks, and is the 360 degrees customer view. Why? Because this is a really complex view, because it implies the need of integrating many backend systems. We have the widest implementation we have is including the integration of 7 different backend systems. So in terms of performance for retrieving all the data and show them into the front end, of bit of a problem, no? So in this case, we have the opportunity of having all the data real-time updated and near real-time updated into a single data source, which is the Cassandra-based data lake, and so from there it's really fast to retrieve the information needed to the front end. Also, an important benefit that it's possible to provide with this architecture is the so-called Google-like search experience, which is something that users are used to work with in the real life, in the normal life, and they really appreciated to have it also on the application, on the front-end application. The third use case is again benefiting of having all the data into a single data space, and is an anti-fraud engine that is, of course, implementing rules based on all of this data in order to real-time rate transactions in order to anticipate eventual frauds. The fourth use case is also a really widespread used situation in which this solution can provide benefits, and is the implementation of self-service applications, maybe web-based or mobile. In this case, it was a web responsive application, so working on desktop, mobile, and tablet. And of course, again, is a situation where you have to enable users to enter screens displaying data, and those data, it's very fast to obtain them by using the data lake. The last use case is just recent, is the implementation of the IFRS financial reporting that we did again based on the data lake. At the end, once one receipt that is a good way to approach this kind of solution is to define a first use case that can provide value, implement it fast, and which is possible to do using an end-to-end solution already prepared for this scope, and then step by step adding use cases, no? And so step by step adding value to an architecture design that you already put in place. So this is what I wanted to share. So thank you for taking the time to listening to this presentation. So I get back to Andy.
Thanks, Giuliano. Thanks very much for that. Yeah, before I move on to the questions, I just wanted to highlight the attachments section in the bottom left-hand corner of your screen. There's some interesting attachments there from both the presenters and some resources there from Datastax. Particularly wanted to flag up the free Cassandra certification attachment there, which is worth about $375, or that's about £300 in our money. So it's definitely worth checking that out. That's in the attachments bit in the bottom left-hand corner. You'll also find some details about some of the webinars we've got coming up, including later episodes of the Technology Modernisation Series. So thanks for doing that. I'm gonna pass my first question on for Ankit, if that's okay. So it's in NoSQL technologies, denormalization can sometimes cause a bit of performance degradation. Is there ways in which Cassandra can deal with that, or in this context?
Yes, absolutely. So you want to ensure, the key is the query-based design model. Whether you be on Apache Cassandra or the Datastax platform, you want to ensure that you're using, the right tools and technologies. So if it's on Cassandra, it needs to be designed around the partition key or the primary key, you can say, to ensure that denormalization is not leading to these bottlenecks. In some cases, you may end up duplicating your data, but that's at the cost. The duplication cost is at the gain of performance. With the Datastax accelerators that we spoke about, you can use enhanced search or your multi-model capabilities to really take advantage of not duplicating the data on disk. So you still have that additional footprint of the additional index or the search capability that you're adding, but you're not necessarily 100% duplicating it, and you might achieve the performance goals that you have. So it's not necessarily a true denormalization, but to some degree, you do need to denormalize.
Okay, thank you. And again, for you, Ankit, you can see there's quite a few questions about sort of the CDC technology needed for this, but what's the real-time data migration approach needed for non-CDC enabled databases? Yeah,
so I mean, really, the real-time approach, I mean, anything that's not CDC, you would implement some sort of polling mechanism if you want to do it after the fact. If you want to do it before or in flight fact, you really have a choice. The only choice, that we've actually entertained with some of the enterprises we worked with is that you inject in additional bits and pieces of the code which pushes the information to the destination system, being RDBMS mainframe, as well as Cassandra at the same time, or you can do it in async manner, saying that I'm going to go in synchronous with my RDBMS mainframe, and in an async manner, I want to put it on some queue, or in an async manner, I want to write it to my second source system, which is Cassandra or Datastax.
Okay, perfect. Thank you. I'm going to switch to you now, Giuliano, if that's okay. It's obviously looking at the solution you put forward and asking whether it's a candidate for substituting a existing data warehouse. Would you recommend that? Would you say that's fair? Or?
Well, look, as I said, our let's say killer use case is to use this solution with real-time ingestion for providing data to front-end application through APIs. Once you have done this, you will have a data lake with almost all the data of your enterprise into a single space. And so you will get, let's say, natural to think about using this also for, reporting or data analysis or business intelligence activities. No? So it would be a good idea to use this solution as a kind of substitution of the typical the staging area that you normally have when you then feed your data warehouse. That's why normally that's because you normally have in your data warehouse also your data marts that are vertical representation of data that you need for your reporting, for example, and so on. And so you would like probably to keep them. So fine, what you can do is to get rid of all the tens, hundreds of extraction procedures from your legacy systems, tens or hundreds of ETL procedures to bring your data into the staging area, and substituting all of this with a much much faster and much more flexible solution. I don't know if I...
No, that's perfect. Thank you. Sticking with you, Giuliano, if that's okay. We've been asked about the implementation, and somebody's asked about some of the challenges. Are you able to share any of those? Some of the hurdles you overcame?
Well, of course, one of the most important challenge that I saw our clients face with is the design of the solution. And that's why we believe that providing an end-to-end solution is a real, very important value, because inside of that there are years of experimenting one tool, the other, understanding the differences, choosing the best one for a particular context. So this is, first a very important challenge. And then once you define to use this solution, the most important challenge is performance. Is dealing with the fact that you really want to have your data near real time feed into the data lake. So you have to manage multi-threading ingestion procedures, but in the same time, it's very important, you have to keep the chronological order of the events that are happening on the source database and replicate them in exactly the same order. So that's, I think, the most important challenge. Last one, also important, is to well design the vertical data representation that you need to really gain that another level of performance when retrieving data through APIs.
Yeah. I thought I might ask the same question to you, actually, Ankit, as well, in terms of implementation challenges from the customers that you've worked at and worked with over the years, and see if there was any particular ones that you could help people get over with who are looking at this kind of technology.
Yeah, so the biggest implementation challenge I've seen is that, let's say you just do decide to use Apache Cassandra, right? So, does it offer the additional accelerators that we've spoken about? And what will it take you to get to those accelerators? That's problem number one, because, when you think from an ERD design model to the NoSQL design model, they're completely different. And you want to ensure that you're taking full advantage of the NoSQL world and not losing on the business functionality as much as you think you would if you were to transfer. And transferring the wrong way can lead to additional project times or elongated processes, which can mean outages in some cases. And you want to really avoid those type of scenarios. And you want to work with partners like Fincons who have experience doing that. More than happy from a Datastax perspective to have that conversation with you. The additional thing I want to mention is the trust. So how do you ensure that the source and the destination are absolutely in sync, and how do you ensure that on a routine basis? And I spoke about that during one of the slides through reconciliation processes. So you want to build an active and a passive reconciliation process, and we've done that successfully with many customers that I work with. I'm sure Fincons Giuliano has actually come across that as well. But you want to ensure that the reconciliation, you can trust the data from the source and the destination. And it's okay if you can find discrepancies, but you want to ensure you address those discrepancies through bug fixes, or whether the process in itself is wrong, and you're able to report on that on a routine basis. So an email alert goes out, or some sort of notification goes out if you find those discrepancies. So, and then over time you build that trust, and once you do that, you can easily lift and shift your application stack.
If I can add just a few words on this, Ankit, because it's really an important topic. It's also important to understand that you probably arrive as a company from a situation where you have daily batches procedure for migrating data, and you're migrating into an architecture strategy where you have real-time, continuously moving of data. So you miss your normal way of understanding if everything is okay, because in the past you arrive in the morning, you see all your batches gone, not gone, eventual discards to manage, restarts, and so on. Now it's different because every second there are data migrating. So it's really key to have a very, very well done monitoring tool that can monitor what happens in all the layers, on the CDC layer, Kafka layer, ingestion layer, data lake, and so on. So to be in the position of knowing in any moment where your data are.
Perfect. Okay, so that's a great tip there. So just make sure that when you invest in this, you're also doing lots and lots of monitoring, because the output will be very different. I was going to end with a question to both of you. We talked around, both presentations were talking about going from a slightly aging infrastructure to a more modern, transformative infrastructure, supported by Cassandra in this case.
Right.
I guess there'll be people on the call today watching this who will be at the start. They'll have this sort of aging infrastructure, and they'll be thinking about going on the kind of journeys that you've put forward today. If you could say sort of one thing to them on why they should be doing it, what would you say, just to give them maybe a little bit of encouragement to put their first step forward in this kind of journey? I guess I'll go for you, Giuliano, first. Yes. So.
Yeah. What's in my mind is what I said before during the presentation. So you have to, as a company, you have to implement your digital journey, your digital transformation. You have to implement your front-end application that must be very fresh in terms of user experience, and this means that they must be fast in displaying things, and also fast in retrieving data. And this is the killer reason for which I saw many clients moving into this kind of data architecture.
Speed. And Ankit, would you support that? Is there anything else you?
Yeah, absolutely. I want to end with a few key words. So, growth is the inevitable future, and agility is also the inevitable future. So you want to ensure that, whatever data platform you choose, you want to ensure that you're able to grow to the next new business demand. You're able to twist and turn your data points at ease. You want to ensure that, you can build those core capabilities which Cassandra offers that we spoke about over and over, and you build those accelerators on top of your data platform that you can easily say that my business need is changing overnight, or over a course of a quarter or a few quarters, and I want to be able to adapt to that business need at ease. In the traditional world, you can argue that it's going to meet that demand to some degree, but it's going to fall apart when you talk about your constraints or outcomes you're trying to achieve from a business perspective.
Perfect. Well, I think that seems like a neat way to end proceedings today. At first, I'd like to obviously thank our two panelists today for great presentations. Thank you, Ankit. Thank you, Giuliano. And Thank everybody at home for watching, and we'll see you again sometime, I hope. We've got 2 webinars next week, so do check them out on the attachments slide with this webinar. So from all of us, from all 3 of us, it's time to say goodbye. So goodbye. Thanks very much for watching, and we'll see you again. Thank you.
Bye-bye.
Bye.